All right, butane. You might be familiar with that. Sometimes they use that in camping cookers. It's a fuel, it's a nonpolar molecule, and water is a polar molecule. They are not like charges. They don't have similar intermolecular forces. Placed in a pressurized tank, they are found to be immiscible liquids. So butane is normal pressure as a gas, but if we pressurize a little bit, it can be a liquid. Which diagram best represents the mixing of butane and water? They don't mix well. So which diagram represents that? So water has hydrogen bonds. They are strong intermolecular forces. To expand the solvent, to separate the solvent, you would expect it to require more energy to separate water than the butane, because butane is nonpolar. It's not going to require as much energy. So I'm leaning toward B right now. Let's take a look at B. This is a little better. We definitely want to see a greater quantity here for the separation of the solvent, because water has those intermolecular forces, those strong ones, and butane would not require as much energy. So these delta H's of separation are endothermic. Here's a clue that it is B, because water and butane don't want to mix. So that delta H of mixing, that's a pretty small quantity. This is an exothermic process, by the way. And you can see that heat of a solution is very positive. So when that's the case, that this is not going to be a spontaneous process. This is not going to mix. Okay, now if we look at the other side, this is not going to be the correct answer, because look at the delta H of mixing. That large exothermic delta H of mixing is representative of a solute and a solvent that have similar intermolecular forces. So it would give off a ton of energy like that when you have two things that want to be next to each other, because they're far more stable that way. So A is not the correct answer. B is best representing water. In this case, is the solvent in the diagram, and butane. So now the second part of the question is, describe the solvent and solute mixed in the other diagram. What could this other diagram be? Well, this other diagram, you have the solvent requiring some amount of energy, and then the solute requiring a little bit more energy. So maybe this is like an ionic compound, because ionic compounds, they have that full positive and negative electrostatic charges attracting each other. So that might require a little more energy to separate than the hydrogen bond. So maybe this is water. This is an ionic compound, and they definitely do want to mix. When they do mix, this is going to be a very large quantity, delta H of mixing. So it's going to be very exothermic. It's going to be negative, and when you have the total of all those delta H's, the heat of solution is, in this case, slightly negative. That is a favorable scenario when you're trying to make a solution. So this is a spontaneous process here. This would be something like water and an ionic compound.